Okay, so by now you should have been able to find the definitions for osmosis, isotonic, hypotonic, and hypertonic solutions, as well as the fluid mosaic model. Okay, so the first interactive that you did was you used the cutouts to assemble your membrane, and you also had access to the toothpicks. I'm hoping that you found those at each one of your desks. But I just want to review the definitions very quickly. So osmosis is dealing with the diffusion of water. Okay, so it specifically talks about water. And the cell has a really difficult time controlling the movement of water across a membrane. So it has to do that from the viewpoint of dissolved substances. Okay, so that goes back to solution, which we say like solutions refer to dissolved things or dissolved substances like salts or other types of minerals or ionic compounds. Okay, so now isotonic solutions, it means equal. So think of the inside of the cell, and I'm going to draw a little picture here just to give you an idea. And let's say that these are 3 dissolved particles. And I also have 3 dissolved particles on the outside. So what that tells me is that water is free to move into and out of the cell. Now, if it's a hypotonic solution, then there are more dissolved particles inside. Okay, so there's more dissolved particles. So let's draw a picture to see what that looks like. Let me roll this up just a little bit. Okay, so let's do this. Okay, so let's say we said that there's more dissolved particles. So let's do 3, and then on the outside, let's just do 1. Okay, now what happens inside the body is that for every dissolved particle, there is 1 less water molecule. Now remember, everything wants to be isotonic. Your whole system, wants to be isotonic. So water is going to flood into the cell. So let's write down water. Because if there are fewer dissolved particles on the outside, that means that there's more water on the outside. And everything follows a concentration gradient. So water flows into the cell. And I remember this by looking at the O in hypotonic. So the cell becomes very O in its shape, very round. The last one is hypertonic. And of course, it's going to be the complete opposite of a hypotonic solution. And it would have less dissolved particulates or particles or whatever you want to say, minerals or whatever. So let's do a picture and see what that looks like. So here we have, I'm going to do the opposite of this one up here. So I'm going to put 1 dissolved particle, and then I've got 3 on the outside. So as you can clearly see, there will be more water molecules on the inside. So all of the water is going to evacuate from our cell. Okay, so there's water, and there's water. And this is going to cause the cell to shrivel. It's going to shrivel up. If I'm hypotonic, then my cell becomes very round and it ruptures. And this is also the thing that causes cell lysis. Okay, and then isotonic means equal. The fluid mosaic model is a great way for us to kind of talk about what the cell membrane looks like. And it's really beautiful. And there is a video that I want you to click on that's going to be in Canvas. And it's going to reflect this activity here. So you have constructed your membrane, you've put it together, you follow the directions. And so now I want you to click on that video that's inside Canvas, it's inside the class, and it's right after this link here. And then watch that video, and then we'll come back.